Everyone, today I want to show you the algorithm for detect the object. And why we talk about this algorithm? Uh, Look like last video we already know about the key point detection and matching the key point descriptors, right? Why we do that? This one is how the CAS system, it means collision avoidance system for the car. Why they use the detect object from the camera. Right now they use the fuse to capture the sensor, the camera and lidar together. The first time they had to use the key point detector to matching key point descriptor. We really understand this one. The second thing, they use the data points from the lidar, right? And they grab the data points from lidar to where they want to detect, right? That's the area on the image, okay? And they will use this data point and project this data point into the image plane. Combined with the detect the object on the image, okay? They use some algorithm right here to get the bounding box of the object, right, on the image, right? And they combine with the lidar data point. They project on the image plane. They combine together. Right here, they got the bounding box and lidar data points on the image right here of the object on the image right here. After that, they combine with the matching the key point descriptor and the bounding box and the lidar data points. They combine together and they track the 3D object bounding box. And after that, they compute the time to collision on the object in front. That's the whole system. CS system work, the principle. I hope you understand this one, the principle, how step by step how we do it. The purpose, we compute the time to collision on the object in front, right? For example, the car. And the second thing, we understand why we use the lidar point right here, why we use the camera right here, and why we need the image key points, why we need the object detection right here. Okay, remember that. And you can see this result. We can the color on the image right here in the bottom box right here. That's the lidar. Okay, data points. They project the lidar point onto the image plane right here, and they combine with the object detection on the image. Okay, from the camera, they create the bounding box right here with the data points with the lidar data point right here. Okay, and right now they compute the time to collision the object in front, right? For example, the car in the front. I will talk about the project the lidar points into the image later in another project. It's a little bit complex and hard to understand. So right now I just tell you why we need it and how right now how we detect the object by the camera. And so as you know, we have a lot of the algorithm, machine learning, deep learning to detect the car in front of the camera right here. And right here I introduce you the Yolo. Yolo is a good one and fast detection of the object. Something like this, they detect the car, the people, okay. And we have some another methods use the horse and support vector machine, right? Support vector machine to detect the object. And you also use TensorFlow or Cafe to detect the object. But today we don't know how to use YOLO, use different approach. And this network divides the image into the region and predicts the bounding box probability for each region. So these bounding boxes are weighted by predicted probability. Okay, for example, the input image right here, they divide into many region image and they predict the probability for each region and they weight on the bounding box right here. That's the result. So the yellow have the available for it means they will have the also made available set of pre-trained weight that's enabled to current version. They can recognize the different object in image and video. So you can reference from the dataset from the coco.org right the link right here. You can go to figure out detail how Yolo work. And so Yolo, the principle they had to first they had image divided into 13 by 13 grid of the cell. Based on the size of the image, the size of these cells in the visual spheres. So each cell then used to predicting a set of bounding box. For each bounding box, the network, and so predict the confidence that the bounding box enclose a particular object, as well as the probability of the object belong to a particular class. So, and lastly, we use the non-maximum suppression is used to eliminate a bounding box with the low confidence, as well as the redundant bounding box enclosed in the same object. So every bounding box predicted by the Yolo, so they are associated with the confidence score, so parameters confidence threshold. It used to remove all bounding box with the low score value, right? The non-maximum suppression is the algorithm to apply to remain the bounding box with the highest the threshold. The size of the input image controlled by the parameters, the width and height. So we use right here is for sitting, so but you can get the about 320s or 603s. It's more accurate. So to repair the model right here, I give you a link about the file configuration files for the Yolo. So they have the Yolo configuration contain the network configuration, okay, and the name of the AD's object, the name of the AD object can you test. Okay, for example, right here. No, right here. You can see they have detected version. This is the configuration file. I type the link for you download it. Okay, they have detect this object ID, the object, and this is configuration file for training for the network. Okay. And here's the code. They load the class name from the file right here. They load the image and they load the configuration file right here. And after that, they load the network right here. And next, after they load in the image, they will generate the 4D blob from the input image. Blob right here means this is a matrix. Matrix array with the AND right here. AND means is the batch size of the data. For example, the batch processing actually is for training batch of the 256 image, AND would be the 256, right? And C right here, and the channel C and width and height. That's a blob dimension when we load in into the network. Before the loading network, we had to generate 40 blob from the input image, and 40 blobs they have the parameter N, C, and height and width. Okay, and that's the 4-dimension matrix array. And this is for example. The output block, so when you generate the 40 block from input image, we have to the bus or the block may go into the network. So a forward bus will be executed to obtain the list of predicted bounding box as the output from the network. This box goes through the most processing step to filter out with the low confidence values. And right now they run the forward bus through the network. The blocks we had to pass the blob we thus created to the network. Okay, and the result of the four work paths, thus the network is the vector subsets the number of blocks class with first out element in each class representing in the center with the center as y and with height associated with the bounding box. The fifth element present right here is the confidence present bounding box actually enclosed in an object. Right here, we scan through all the bounding box and keep the only one with the high confidence. And applies the Yolo algorithm, we can gauge the image with the bounding box like this. And we can see the car they cover by two bounding box similar. For example, right here, they maybe can cover two similar. So to avoid current redundant spots, so the last step we use the maximum suppression with support which have to keep the only bounding box with the highest confidence score. So the last step we use the non maximum suppression. Mean from here they have a lot of the bounding box cover one object. So right now we just only got the highest one with the highest probability. Okay, we apply the non maximum suppression then bounding boxes will be successfully removed. Okay, and you can see the green indicates preserves bounding box, while the rest the bounding box have been removed during the non-maximum suppression. That's the result we want. Okay, that's the Yolo algorithm help us to detect the object in front of camera. Um, So I don't want to tell detail about this. You can go to the website, the Coco Yolo website, and you figure out detail how this algorithm work. And from the input image, and got the predict the probability by the cell region right here, and I got the weight bounding box right here. So right now we jump to the code to see how the codes work and how they detect the object. And right here, for example, I load in the image first and see how they use the Yolo to detect the object. After that, I will run the camera to detect the object around us. Okay, right now we load in the image, we load in configuration file right here. And after that, we are loading the network. We generate 4D blob from the input image right here, and then we get the name from the output layers, and then we got this. We scan through all the bounding box and keep only one with high confidence. Okay, and then we apply the non-maxima suppression. Okay, to get the highest probability of the bounding box. So the last one we show the result. Right here we have the image right here. Image we have a lot of image right here. For example, I want to image with one. I want to for example detect the object before in front right here. How the Yolo can help. Okay, let's see. Here's the result. You can see the detect the car, the people, and the stop sign signal right here. And they can detect the the traffic, the people right here. They can detect the person. So from my back, our purpose is create environment bars of the object right here. And after that, we apply and we fuse the same lidar point data into this region. And after that last step, we calculate the time to collision to the object in front of camera. And one useful thing for the Yolo is help us to detect the object quick, and we give us the bounding box with the position, okay, and from that you can get the position of the object. You publish or subscribe in the rows. You can ask the robot can do something else, okay. I like this one. I think I will transfer this one for the robot in the future to recognize the detect object, okay, for the robot, and ask the robot do something. For example, if the robot know this position for its object, they know how we ask them to do something, right? Okay, you can see they give us the bottom bars with the position of the bottom bar X and Y. From here, we can publish on the raw system. They know the position, and you can control that motor of the robot. Okay, here's the picture. So what the camera the detect is yeah, that's the useful thing. Right here, we read the camera and we put onto the folder. Right here, that's attached to the library from the OpenCV, and we have to they did as per right here. We read the camera, divide the camera right here. I read from the webcam. So you can on the computer you can use the USB camera. Maybe the device name is different, not 00 default for the webcam camera. So for the outside for USB camera, maybe 1. You can try it, and you do the same thing. You run the follow-up. You read the frame of the camera, okay? Read frame by frame of the camera. And last time we read right here is the image. Maybe 1 frame right here. We read the many frame from the camera. So right here you can read frame by frame, and you do the follow-up right here, and you read frame by camera, and you apply the same Yolo to detect for each frame, okay, and show the image. For my laptop, it's really slow, and maybe take about 5 minutes to work for one. I don't know, 5 or 10 seconds for 1 frame. It's really long, so you can use your laptop, your powerful with a graphics or processing unit CPU. It's run faster than my computer. But right here, let's show you how they work. Okay, but my computer is really slow to read the frame by frame from the webcam camera. Here's the camera, so the webcam camera is very slow on my laptop. Because my camera and my computer is really slow. Anyway, that's the algorithm you use to detect the object. Okay. So next video I show you how to project the uh, data point cloud into the raw image plane, something like this. This first step we use the deep learning how to detect the object. Okay, and after that we projected the point cloud data onto the object detected right here, and then we calculate the time to collision. And after that, we know how long it takes to get the object in front of the camera, and we apply the brake automatically. Okay, that's the purpose of our system, CAS system, Collision Avoidance System. So right now, you understand why and how the deep learning is useful for us to calculate the time to collision. Okay, and this is the whole picture right here. It shows you our system work. Okay, see you next time.